Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 4 of the daily Leetcode challenge of the January month. Past few questions have been on the easier side. I will say that day three's question was on the medium side, but still it was slightly easier, that beam question. But today we have a very interesting question, and believe me, you don't need any data structure kind of knowledge to solve this kind of question. This is purely, logic based, and it's purely based on how much your thinking is, okay? How much you can think and how much you can simulate this, scenario in your mind, okay? So let's see what today's question is, and believe me, it's very interesting question, okay? It's totally about maths. So the question is 2870 minimum number of operations to make array empty. So remember this part. This part is going to be very important. Make array empty. Okay. So the aim here is to make the array empty. We'll see that how. So just see the inputs first. We are given simply a array. Okay. And we have written integer as the output. So let's see the question now. You are given a zero indexed array called nums consisting of positive integers. One thing is clear, the integer is going to be positive. This is a very important part in our solution, so please highlight these parts. It's going to be a positive integer. There are two types of operations that can be applied, okay, on the array any number of times, okay. First operation is that if two elements are equal, okay, in values, you delete them from the array, okay. You are deleting two elements if they're equal, right? In this case, you are deleting three elements if they're equal, right? So this is called one operation, this is called one operation, okay. So, but what are the things? There are two elements are equal, you are deleting them, okay. You are deleting both of them. If three elements are equal, you are deleting all three of them, okay. Now the question is, return the minimum number of operations required to make the array empty, okay, or return -1 if it is not possible. So see both of them count as only one solution, okay. If you do this also, you will be counted as single solution. If you do this also, will be counted as a single solution. So please use some logic now, which is more efficient. See, ultimately you have to make the array empty, right? So if you are able to remove three elements in place of two elements, which will be more efficient, obviously this will be more efficient. So the idea here is, if let us say you have a number 6, okay. So 6 can also be removed using two elements, and 6 can also be removed using three elements, okay. So basically, if you try to remove 6 elements using two, that is, you have to do 2 plus 2 plus 2, right? That is 3 times. So you will have to do three operations. But if you try to remove 6 elements using this approach, so you will have to do 3 plus 3, which is two operations only. So which is more efficient? This is more efficient. So whenever possible, as much possible, we will try to implement this solution first, and whatever values are remaining, we will try to implement this solution. This is going to be my approach. So if you want to understand my approach, please understand this first. Wherever possible, I will try to do this first, okay. Wherever possible, I will try to reduce three elements at a time first. Whatever be the remaining ones, that I will try to do with two elements. And remember, if this cannot be done, you have to return -1. Okay, let's see the examples. Now, yeah, this example first. Okay, so simply see the example won't help you. Okay, by the way, so let us try to understand what is happening here directly. So you can see 3 is present. Okay, 3 times. Okay, so how many times 3 is present? It is present 3 times. So which operation will be more efficient here? Obviously, this operation will be more efficient here. Okay, this operation will be more efficient here. So yeah, in one operation we removed all the threes. Now come to the other part. So yeah, threes are removed now. So now coming to 4. How many fours are there? There are two fours. Okay, there are two fours. There are two fours now. So what operation we can use? Obviously, we cannot use this, so we have to use this only. So again, we will do one more operation. So total, how many operations now? Total, we have made two operations. One operation to remove 3, one operation to remove 4. Now coming to the part of 2. How many twos are there? By the way, there are 4 twos. Okay, there are 4 twos. Can I use this now? Can I use this now? Obviously, no. Try to understand. See, if I remove, see, there are 4 twos. Okay, let us say there are 4. Okay, there are value is 4. If I remove 3 out of them, the one will be left. Can I remove that one? See, that one cannot be removed by either of them. Either of these ways, I cannot remove a single element. Okay, so I should not use 3 in this case. If see, I have 4 twos, right? So I have to remove them using 2 and 2. That is 2 approach only. Let us remove first 2 and then remove next 2. Okay, that's what it is. So basically, you will do this operation for 2 times. So previously we did 2 operations, then we will do another 2 operations. So what is the answer? 4. Remember, we cannot see. I will just trace and show you that. But remember, whenever the answer is this, this part will form a example in our solution. Whenever you have a value 4, that is a single. Let's say value x is present 4 times. You cannot use this code. Okay, you cannot use this, because remember, your aim is to make the array empty. So if you do this, maybe you can remove 3 elements, but remember one element will be left. Okay, so how you will remove that single element? You cannot remove single element through this. Okay, similarly you cannot remove a single element through this. That is the basic constraint of this question. Okay, so that's why 4 is the answer in this case. Next example will make it very very clear what we are doing. See this and try to tell me the answer. There are how many twos there? There are 3 twos there. Okay, so how many operations I needed? One operation. Why? I will directly do this. Okay, I will directly do this. But yeah, now coming to 3, how many threes are there? There are 2 threes. How many operations you need? One operation. That is, we'll remove both of them together. But what about this? There is a single one. Is there any way I can remove a single one? Both of them will fail to remove a single one. So the idea here is this array cannot be made empty. You will have to return -1. Okay. So this was the idea. Now let us see what we can code. Okay. First thing is very clear. We need the frequency of the elements. Okay. So if you have been following my video, I'm sure that you will be, bit thorough with this. Okay. This is called a mapping or a dictionary in Python, and I'm going to use this to store the frequency of the elements. Okay, so the key will be the number and the value will be the frequency. So so I'm going through all the elements of the array. Each of them I'm calling as I. When if I'm noticing that element for the first time, I will initialize value with 1. If I'm noticing that value for I already noticed that value, and this is the second time it is appearing, or any number of time it's appearing after the first time, I will simply increment its count by 1. Okay, I will increment its count by 1. So this is basically the frequency array. It will store the frequencies. Okay. If you want me to print and show you, if you are a, maybe you will be watching my video for the first time, you may not be knowing what it is. So let me quickly print and show you. Okay, so let me go to case 2 directly, and then I will show you. So in this case, 2 is present for 3 times. Okay, similarly 1 is present for 1 time. Okay, so basically this, these are called key value pairs, right? The value is representing the frequency. Okay, similarly as you can see, 3 is the number here, 3 is the number here. It is present for 2 times. That's what it is. Okay, I hope you have understood now. So that's what it is. And then I'm declaring, let me comment it out quickly. This is the answer, by the way, and we are finally going to return this as the answer. Now please pay as much attention as you can, because this is going to be complete maths now. Okay, so I'm going to go through the values now of the frequency. Okay, I'm not bothered about the keys, by the way. I'm bothered only about the frequencies. Okay, so frequency that value means I'm only going to do the values. Okay, for example, in this case 2 is present for 3 times, so 3 I'm going to go through. Okay, similarly as you can see 1 is present for 1 time, so that one I'm going to go to. So this I'm going to go to the frequency of values. Okay, try to understand this fact what I'm doing. See, in a map there are two components, keys and values. Okay, if I want to go through only the values of on all the possible keys, then I will use this. Okay, frequency dot values. Okay, so what I'm doing, if the frequency is 1, as you saw in this case the frequency of 1 is 1, if that is the case, I am no position, there is no way I can make this array empty, so return -1. Okay, then as I mentioned, I hope you remember what I said in the beginning of the video. Wherever possible, as much possible, I will try to do this first. Only for the remaining elements I will do this same approach I'm going to do. So first I'm taking reminder, that is I modulus 3. But that is, if I try to reduce the number of values by 3 at a time, how many values will be left? Okay, remember, this is not a divide operator, this is a modulus operator. It will return the reminder. That's why I've kept the variable name as reminder. Okay, so if the remainder is 0, that is, if I can remove all the values with a multiple of 3. Okay, that means I can simply do that. Okay, I divide by 3. What is this divide symbol, by the way? If you know to Python, what is this? This is called a integer division. So the answer will be integer. Okay, or the integer part of the answer. It will not have floating point values. Okay, so I'm directly adding that to my answer. For example, if you have a value present for 6 times. Okay, so what? So remainder will be 0, right? If you do a modulo by 3, it will be 0, right? So what I should add to the answer? I should add 2 to the answer, because 6 divided by 3 is 2, right? So 2 will be added to the answer. Similarly, if you have a value present 12 times, what you should do? You have to divide it by 3 and you will add 4 to the answer. Okay, you will add 4 to the answer. So these are the values of I for which this part of the code will be executed. Okay, now let me jump to the case where, see, this is a part of the code where reminder is 1, this is the part of the code where reminder is 0, and this is the part of the code where reminder will be 2. Okay, so let me complete this first. Okay, when the reminder is 2, let me complete this part first. Okay, so when the reminder is 2, what you can do, try to understand this value. When the reminder is 2, see, these are the various cases for which the remainder will be 2. For example, see, 5, 8. Okay, if you try to talk about it, what we can do, see, what is 8, by the way? 8 is going to be 6 plus 2, right? 6 plus 2. this 6 I can remove it using a multiple of 3, right? So I can directly choose this way. Okay, I can remove them using threes. Okay, multiple of threes. Okay, but this 2 I cannot remove using multiple of 2, so I will remove it using this approach. Okay, so try to do what I'm seeing. If I have a value which is present 8 times, what I should do, I will, try to remove it using multiples of 3. Okay, so how many operations I have to do? I will do this operation. Okay, that is, I will remove threes of possible, all possible threes I will remove. Okay, so I have to do this operation 2 times. Okay, 3 into 2 is 6, right? So I have to do this operation 2 times, and then I will remove the remaining 2, which can be done using a single operation. Okay, so for 8 values, how many operations are needed? It is 2 plus 1, which is 3 operations are needed. Okay, so I hope you have understood what I'm doing here. Okay. Similarly, if you talk about 11, what is 11 by the way? It is going to be 9 plus 2, right? So 9 is a multiple of 3. Okay. So this I will be, see, the first 9 values will be removed using this operation. The remaining 2 values will be removed using this operation. Okay. So that's why the answer in this case, what I'm going to add, I'm going to add 2 components to the answer. This one basically represents this 2. Okay. This last remaining 2 represents this. Okay. This one, because it will be one operation, this particular operation. Okay. This one operation I will do here and remove these 2 values. Okay, and how to remove these 9 values, I will do that using this thing. Okay, and how to do that, I will divide it by 3. Okay, integer division with 3. Okay, so if I have a value 11 times, what I should do, so 9 divided by 3, which is 3. So 3 operations here, and for this 2, one more operation. So 3 plus 1, 4 operations to remove the 11 values. Okay, I hope my answer is clear to you. Now come to the most complicated part here. When the remainder is 1. Okay, when the remainder is 1, what we have to do, there are various values for which the remainder can be 1. Okay, what are the values? 4. Okay, 7, 10, and 11. So let us see one of them, one, okay, at a time. So what is 4 by the way? It is going to be 3 plus 1. Okay, and what is 7 by the way? 7 is going to be 6 plus 1. So if I try to see this approach, if these 3 values I try to remove using this, okay, that is fine. But what about this one remaining? Will I be able to remove it? Definitely you will not be able to remove it. See, this point I've already discussed here, right? We have already discussed this, okay, in the first example. I don't want to waste much time on it, but just for now bear with me. Okay, so similarly, when you have 7 values, see, try to understand this 6 can be removed using this approach. Okay, I will remove 6 as a multiple of 3. That is as a step by step process with 3 elements at a time. Okay, but what about this one remaining? Can I remove it? No, you cannot remove it. So what I will do is that I am including 2 steps here. Okay, if the value is greater than 4. Okay, so what are the values in this case? 7, 10, and 13. Okay, but for them I have a different approach. If the value is equal to 4, for that I have a different approach. So what I am doing is, instead of okay, just let me erase this again. So the idea here is, see, instead of, see, for 4 I have a different approach which I will explain you now. But for all the other elements, it's 7, 10, 13, on all those things, I have a different approach. Okay, so what, see, for example, 7 I will add is at 4 plus, in this case, 3. Okay, similarly 10 will be 4 plus 6. Okay, so these 6 elements I will try to do with the 3 elements at a time approach, and these 4 elements I will try to do using 2 elements at a time approach. Okay, so this is what I am doing. So when we talk about 7, 10, and 13, what I should do, basically I will do it, subtract my 4. Okay, and then I will do it integer division by 3. Okay, why I'm subtracting by 4? Because those 4 I am going to do using this approach. Okay, so if you do this approach and if you have a number 4, so how many times you will do it? You will do it for 2 times, right? So those 2 I am adding it here. I hope you are understanding my approach. See, 7 I am going to break it as 4 plus 3. Similarly 10 I am going to break it as 4 plus 6. What will be 13 now? 13 will be 4 plus, in this case it will be 9. Okay, okay, I am not able to zoom it further, just a second. So yeah, the same thing. Okay, 4 plus 9. So these 9 I will try to remove using this approach. Okay, that is 3 elements at a time, and these 4, okay, the remaining 4 I am trying to remove it using a 2 at a time approach. Okay, so obviously the 4 is fixed. See, if you see, for all these elements, 4 is fixed. Okay, 4 plus something, 4 plus something, 4 plus something. So for that 4, I'm adding 2 to the answer. Okay, because I will need this operation 2 times. Okay, and for the remaining elements, that is I minus 4 elements, I will do integer divided by 3. Okay, and that will give me the number of operations needed. Okay, because I will do this operation, so number of this kind of operation needed will be given by I minus 4 integer divided by 3. Okay, this is what I'm doing after that. Okay, and for 4, that is for I equal to 4, I'm doing a separate case. Okay, this is a separate case for 4. For 4, I will do this operation 2 times. Okay, so I answer plus equal to 2. Okay, now you will ask me why I have not included I is equal to 1 here. So by the way, I've already included that here. Okay, whenever I is 1, I've already included that, I've already ruled that case out. Okay, so by the time we come to this part of the code, I will never be 1. Okay, it will always be a number greater than 1. Okay, so yeah, that's what it is. So basically, whenever the remainder is 1, there are two cases. If I is greater than equal to 4, if I is greater than 4, I will follow this approach. If I is equal to 4, this is the approach. Okay, so yeah, that is all. So see, if you want to code this kind of solution, the basic idea is this thing. Okay, see, both of them are called as a single one operation. This is also called as one operation, this is also called as one operation. Which of them is more efficient? Obviously this is more efficient, right? This is removing 3 elements at a time, but this could only remove 2 elements at a time, right? So the idea here is I will try to do this approach as many, I will try to do this kind of operation as many times as possible, and only for the remaining elements I will do this operation. So this is what my code is. Let me zoom out. So yeah, I have already, I think, yeah, I've, though I have created notes here, but I explained here itself. So yeah, this is the same thing which I'm doing here. See, 7 can be written as 1 plus 6, right? You might be thinking that this 6 can be removed using, you know 3 at a time, so this operation. But what about the remaining one? That cannot be removed, right? So that's why we will always break these things as 4 plus something. Okay, so whenever the remainder is 1, in those cases what we'll do is we'll check if the number is greater than equal to 4. If it is so, what we'll do is we'll remove 4 from it. Okay, and then for the remaining element we'll try to remove them using 3 at a time approach. Okay, and for the 4, what we'll do, we'll use this 2 at a time approach, and obviously we'll have to use it for 2 times. So that's why we're adding 2 in the answer, and we are doing this thing. Okay, I minus 4 mod integer division by 3. So yeah, fine, that was it. And let me quickly run this and show you, so that you can verify if this works or not. If this is syntax free. So as you can see, the answers are getting accepted. I've already segmented the solution and it works. Okay, I will give you this in the comment section. You can go through it and yeah, you can explore further. Okay. So yeah, friend, that was all for today. If you have any other, approach which you feel is, better than this, please do comment below. But see, I feel that this kind of questions, see, there are no, data structure or some knowledge, all those things required here for this kind of question. This complete maths, right? I hope I've, done it in the most, appropriate approach possible. Okay. So if you talk about the space and time complexity, see, obviously the time complexity is going to be O of n because I'm using a single for loop. And if you talk about the space complexity, okay, the space complexity is going to be see, I'm using a frequency thing. So yeah, frequencies will be involved here. So frequency, this space complexity is going to be the number of distinct integers present in this. Okay, so that is going to be the space complexity of it. Okay, the space complexity is going to be the total number of distinct values present here, because we have that many number of keys and values. So yeah, that was it. And see, obviously in the worst case, the space complexity is going to be O of n. Okay, what is n, by the way? N is going to be the length of the nums array. So yeah, friend, that was it for today. And yeah, if you have any doubts, please do comment below. See, this why I'm creating videos, why I'm trying to build a community, is because we can discuss approaches. Okay, see, I may feel something is correct, I may feel something is best, but it may not be the case. See, once you come to IT industry, you'll get to know that there is something called peer review. Okay, there is something called code review. All these things will be there. So your code will be watched by many and they will give you comments in that. Okay, so please do that. If you feel anything is wrong in my code, please do comment out. Please do suggest things that yeah, you can would have done like this, you could have automated it like this. Please do that, because I really appreciate those things. Okay, and when you do that, you will get to know this code even better. Okay, so you will try to, if your intention is to find mistakes here, you will go through this code even more detailed way, and you will understand a lot of more things. Okay, so if you're a beginner, please focus on those things. You may not be able to write your code, okay, but you can definitely go to others code and learn from it. Okay, in that way you can develop your ability to code. So that's what I did, and that's what I will suggest you. If you do these things, believe me, one day you will get to know that you have created, see, your total life will change. See, once you get into placements, these things will totally change your life, right? you will be from nowhere, but then you will directly reach the top of the world, right? That's what it is. So yeah, fine. That was all for today. If you have anything, please do comment below. We can definitely discuss it further. Thanks a lot.